the input of the initial data. So let's start the program. So we need to create a shelf stand type block. So let's name it bit 4. And let's start the graphic interface of input. So now we enter the sizes of the block. X 200, Y 100, Z 100. So let's enter the thickness of the block walls, each 1 millimeter. So, and let's enter fastenings of the block at 4 corners from the bottom. So we allocate the fastening plane. We enter radius of the first fastening point equal to 5 millimeters. So we enter the coordinates. So 20 millimeters on X, 20 on Y. So similarly, we entered 3 other points of fastening. So after that, we shall set checkpoint on the block cover. So we enter coordinates, 100 on X and 50 on Y. So we need to enter the material of the block case. Take it from the database and, for example, AMG3. So let's make the block transparent and enter the number of boards. So let's make them 3. Material of the first board we took from database, CF135. And input thickness of the first board, which will be 1 millimeter. Then we enter distance of the board from edges, which will be 20 millimeters. Then we input weight of ready elements mounted on the first board, 0.1 kilo. And similarly, we enter 2 other board parameters. We enter material, thickness, distance, and weight. And the same for the other parameter, at the parameter of the board. So all the boards are set. Now we need to enter parameters of the board fastening. 4 fastenings at the corners with a diameter of 3 millimeters. Add 1 second and add the rest too. So we select the second variant fastening. Now we need to enter the diameter of the pins. So we input 1 millimeter for them. And enter pin material from the database, AMG3. So we set mesh parameters. It is possible to set it automatically. However, it is a long time process, and therefore we shall set mesh manually. We input 19 millimeters. So recommendations for setting the mesh is available. So we could set mechanical effects. Harmonic oscillation. We input the first point with frequency range 20, acceleration 1g, second point 300 Hz, with acceleration 1g, frequency step 30 Hz. So we have it on the z-axis. For random oscillation, we input the first point with frequency range 20, spectral density 0.01, the second point 300 Hz, the spectral Solarge density 0.1 square G on Hertz, and frequency step 30 Hz. So single shock duration will be 5 milliseconds. The pulse of the triangle form, peak shock acceleration is equal to 40 G. So we input point by point. First point 0, acceleration 0. Second point 2.5 milliseconds. Acceleration 40 G. And the third point 5 milliseconds. Acceleration 0. So we have entered triangular impulse. We apply, and then we could save the project.